We'll try to record it. If quality is any good, I will post it. But if it's not good, I won't. So don't rely on me post that I'll post this. I may or may not do it. So as you will see, only first question deals with chapter 1. Everything else deals with chapter 2. And as I already said, that's because there is already video under organic chemistry lectures on chapter 1, and that's general chemistry review. So, first question, which of the following compounds contains the largest number of sp2 hybridized carbon atoms? That's kind of question, this kind of typical questions we like to ask where you apply your knowledge. There are a number of reasons why I like to ask a question like that. One is, of course, you're applying your knowledge. That means really I can see whether you understand it. So that's higher level of learning than just being able to recognize which of the, if I were to show you a number of carbon atoms, which one is sp2 hybridized, or what is sp2 hybridized, or some other basic question like this. This is a little bit more advanced because you have to be able to identify sp2, in this case sp2 hybridized carbon atoms, and distinguish them from sp and sp3. Also, that helps identify misconduct because if there is, that's easier to show because in this case actually it's A, B, C, D, but if I'm asking open-ended question, that's even easier. For example, I could ask, if it were an open-ended question, we would still have A, B, C, D, but there would be a line underneath in Canvas for you to type up the answer. And so, for example, the question could be, which of the following compounds contains the largest number of sp2 hybridized carbon atoms, and how many sp2 hybridized atoms it contains? And then, if there is something out of the ordinary that several students share, then that could be indication of misconduct. It would make me look more into it. The reason why I have to do it, obviously, is a lot of you will be taking exam at home or in a dorm room or maybe in a library. And so there is possibility for communication, for working together, all of which is misconduct. And this is the only way. If you were all taking the exam here in the classroom, then obviously it will be easier to control the conditions. So what you simply go about is counting number of sp2 hybridized carbon atoms. Those are carbon atoms, since in this case we have multiple bonds, and there are no other structural elements that would indicate sp2 hybridization, like let's say carbocation or a free radical, presence of atomic p orbital. There are only pi orbitals that are due to presence of multiple bonds. You look for carbon atom that forms only one pi bond, one double bond. In this case, I would use pen and paper. You should always have pen and paper, even though you're answering questions on a computer, and work it out on pen and paper. So A, you would write for A, you see 1, 2, 3, 4. So A has 4 sp2 hybridized carbon atoms. B, 1, 2, 3, 4, also 4. So from this already you can come to a conclusion that neither A nor B will be correct answer because they have the same number. There must be some compound with more. C has only 2. Triple bond is sp hybridization, and so there are 6 sp hybridized carbons, but only 2 sp2. So D must be correct answer. And yeah, you can find here 1, 2, 3, 4, 5, 6. This is easier compared to open-ended question where you have to type up the answer, because here all you need to do is guess that D is correct answer. If it's open-ended, and let's say I were to ask you also how many sp2 hybridized carbon atoms there are, then to get credit you need to answer 6. And somebody may answer 8 and count these 2 that are sp hybridized. So that just gives you an indication of all the questions that could be on the exam. And in this case, I'm asking about sp2 hybridized carbon atoms. It could be any other feature. which of the elements contains, let's say, atoms, the most atoms that are more electronegative than carbon, or less electronegative than carbon, or something like that. So any of those features that we have covered in chapter 1, a question like this could be asked about. And now we're going to move on to main point of today's class, which is chapter 2. So which of the following is a correct representation of a tetrahedral carbon atom by means of perspective formula? So these four formulas, A through D, are perspective formulas because they represent three-dimensional arrangement of substituents in space on carbon atom, in this case carbon atom. We can use any atom as central atom. So lines in the plane of the drawing, solid lines are in the plane of the drawing, wedge projects towards the viewer, and dash away from the viewer. And so you need to know which of these four represents the tetrahedral carbon. It's B. A is kind of close but not quite correct because it represents this as in form of a cross. And that's not actually not quite correct. It's A is sort of iffy. In fact, this is a little bit arguable case, but we usually don't represent them as a cross. B is correct. C is not correct, and D is not correct. Now, why C and D are not correct is easy to figure out. For C, all of the bonds point to one side, to down, point down. And if you try to make a model, you couldn't make a model from this. C is actually easy to figure out. And by the way, these models could be rotated, let's say upside down, 90 degrees or any angle, and it's still not correct. D is not correct, and that's more difficult for students to figure out. Sometimes students view this, well, if I view molecule from the top, it would look something like this. Actually, it doesn't. So you can't really make a model from this. When one bond points up, one points down. One wedge, one dash points up and down. Basically, for a model to be correct, if you draw imaginary line that cuts the carbon atom in half, so that two substituents in the plane of the drawing are on one side and two that are not in the plane of the drawing, towards and away from you, on the other, they have to be on the same side. So when two in the plane of the drawing have to be on the same side, and two that are not in the plane of the drawing have to be on the same side. So that's what is wrong with D. And this is D from another angle. And it's also what is wrong with C, because if you draw anywhere that line, you cannot draw a line through the molecule that represents molecules on the same side. And actually, you see this, I had this question on the test, and I remember actually I changed A, answer A, because strictly speaking, even though we don't like to represent molecules like that, this is technically correct. Although when we see, because you see when you rotate it 45 degrees, actually it's a bit more than 45, that's 135 degrees clockwise. Actually, well, and make a mirror image. Then it's correct. Then it's this representation. Simply, this representation is rather unusual. But still, if you draw a line like this, you would have two bonds in the plane of the drawing on the same side and two that are not on the other side. So technically, A can also pass as a correct. What that also means is that sometimes when in doubt, so you need to select the best answer. Although, as I said, for the exam, when this used to be an exam question, I changed A. And basically the way I changed A was I flipped these two bonds. So this wedge bond became solid, and this solid bond became wedge. And then it's obvious that it's not correct. But anyway, in case like this, when in doubt, select the best answer, and that would be B. Okay, any questions about this? Let me see if there are any typed up questions. No. This line here is only to show you examples of line forms. There is nothing, there is no question or anything. It's only to show you that, for example, when we draw line formulas, if there is heteroatom, atom other than carbon or hydrogen, any hydrogen attached to heteroatom has to be shown. So we can't simply represent here oxygen. We have to say OH. And here are some examples of heteroatoms as part of line formulas. We always have to indicate heteroatom. In a line formula, only carbon and hydrogen are assumed to be there. Any other atom has to be indicated. And you can see how multiple bonds are represented. And this last example, again, we have nitrogen heteroatom, so hydrogen attached to it has to be shown. And then nomenclature. You can expect nomenclature questions to be on the exam. And by now, actually, I think most of the students are in the class. Actually, before we go, I think rest is nomenclature. So let me just check. Well, actually, yeah, some students left. Okay. So what I wanted to say is I'm getting inquiries about the exam. I don't have information about the exam, especially for those of you who are asking. Once I know when the exam will be, I will inform the entire class. I think that I will know next week because I need to know how fast I will cover the material and then when it's convenient day to give you an exam. So I think I will know next week after Wednesday. Maybe Wednesday class or maybe Thursday or Friday. Since Wednesday we have a class, then if it's after Wednesday, then I will provide email and post under announcements when is the date. So you can expect that time. So probably Thursday, Friday next week. Okay, so let's go to nomenclature. So when it comes to alkanes, you should assign smallest possible set of numbers to substituents. So something like this. On the test, if you have to name a compound, always redraw it. So redraw it from a screen, but be careful not to make a mistake when redrawing it, because that's always a problem. When redrawing something, you could make a mistake. So make sure you redraw it accurately. And then when you identify the longest chain, in this case it's horizontal zigzag chain, number it both ways, from left to right, right to left, and see which one gives the smaller set of numbers. In this case, it's actually the same, 3, 4, 3, 4, two substituents. So you have hexane, 6 carbons. And then left to right, ethyl group is 3, methyl is 4. Right to left, methyl 3, ethyl 4. You have a tie. Each way you have 3, 4, 3, 4. When it's a tie, then ethyl gets smaller number. So first listed gets smaller number. So it's 3 ethyl, 4 methyl hexane. That would be simple question. More complex would be something like this. In fact, this would be, when it comes to alkanes, about as difficult as it gets. And the reason for it is that when you are looking for the longest chain, there are several chains that have the same length. So you can see 2, 4, 6, 7 shown in bold. Or here 2, 4, 6, 7, another chain shown in bold. And yet another one, also 7. Then you indicate each chain when you redraw the molecule, indicate each chain that you suspect is parent chain, and count how many substituents are on each chain. On the first chain that has 7 carbons, you have only 2 substituents. On the second, you have 3, methyl, propyl, and isopropyl. And on the last one, you have 4. You have methyl, propyl, another methyl, and ethyl. Chain with the largest number of substituents is the parent chain, because that one is the easiest to name. because then substituents are smaller and naming is simpler. And then again, you number it. So that this last one is going to be the parent chain. And so you name it, you see you have two methyl groups, so it's going to be dimethyl. If you have ethyl group, it's going to be ethyl and propyl. So it goes ethyl, methyl, propyl alphabetically. So it's going to be ethyl, dimethyl, because there are two methyl groups, and propyl, and then heptane. And you need to number it, so you number chain both ways and find which gives smaller set of numbers. It's shown here in black. It goes from the bottom up. Those of you who are using ChemSketch or some other computer programs can find their feature to name compounds. So you simply draw a formula and select it and select name this compound, and it will provide you a name. That's actually cheating. That's misconduct. Because you're supposed to name this compound, not a computer. And as it happens, I don't know why, but all these computer programs name compounds using European variation of UPAC nomenclature. Since we are in North America, European nomenclature is not acceptable. That's not what I teach in this course, and that's not acceptable. If you try to publish a paper, let's say in Journal of American Chemical Society, they would ask you to change that to North American nomenclature. So we don't use that nomenclature here. So for this compound, you can see the longest chain is already numbered appropriately, in this case from right to left. 8 carbons, it's octane, and substituents are ethyl group and isopropyl. So if you were naming it, you would name it 4-ethyl 5-isopropyl octane. Computer would name it different. And here are different computer programs that name. So even though it's UPAC nomenclature, it's supposed to be standard, there are different ways to name this compound to be correct. So 4-ethyl 5-propane 2-iyl octane. Rather unusual. I don't remember which program it was. 4-ethyl 5, and then in parentheses again, 1-methyl ethyl octane. That's much more common. Most computer programs would name it like this. And then 4-ethyl 5-2-propionyl octane. All these are correct, but none of those I would not accept any of these. First, I'm not teaching you how to do it, and if I were to ask you to explain how did you name this, would you really know how to do it? Which is first thing I would do. After the exam, I may want to talk to some of you. Now that may be misconduct, but you shouldn't right away get excited about that, because there may be other reasons why I may want to talk to you. So something like this, if I were to see names like this is not what I taught in the class. These names are not usually in organic chemistry textbooks. This is either computer-generated name, or it's a name that somebody, let's say a graduate student or PhD in chemistry, generated. Because if you got somebody, or not you, I mean, a student got somebody to take exam for him or her, and that person is, let's say, PhD chemist or graduate student, that person is not taking my class. That person doesn't know what you are supposed to know. That person has his or her own knowledge, and simply is answering this question correctly, the way he would do it at work. And that's right away to me a tip of this. That's probably not a student. That's probably not one of my students who is answering this question. Okay. Then when it comes to parent chain, obvious mistake the students make is that assume that this horizontal zigzag chain is the parent chain. And in this case, you can see it's not. It's actually, it goes from here and then down. So this compound is 4,7-diethyl andecane. And you can redraw it by straightening this chain and settling this chain and seeing that this is ethyl substituent. Basically, you move this part up and then ethyl also goes up, or actually down. Here is another related compound for 7-diethyltecane. Again, chain goes down. So you may want to practice on these two. As you can see, less information is provided compared to previous ones, so that on these you can work on your own using information from previous examples, where you identify the longest chain and then number it one way, the other, and see that you come up with correct answers. That's simple nomenclature of alkanes. Okay. Okay, first question. If propyl is tied with ethyl, ethyl will still go first because of alphabetic order. Yes, you always list them in alphabetic order. Can butyl have a smaller number than ethyl? I don't know what that means, but butyl comes alphabetically before ethyl, so butyl would be listed first. And so in case of tie, it would get smaller number. Alkanes are the simplest compounds to name, simplest nomenclature, but they are basis for naming everything else. And so everything else gets a little bit more complex. So cycloalkanes, very important. So when it comes to cycloalkanes, if they are monosubstituted, make sure that you name substituent correctly. So you name substituent and then longest chain, usually the ring. And if they are monosubstitute, trick is naming substituent correctly. In this case, that's propyl. This is isopropyl. It's a 3-carbon, still propyl, but bonded to middle carbon. That makes it iso. And this is secondary butyl. Straight chain butyl, but bond to second or secondary carbon. And so propyl cyclopentane, isopropyl cyclopentane, S-butyl cyclohexane. When cycloalkane is monosubstitute, you don't use number 1, even though carbon of the ring to which substituent is attached to is carbon 1, you don't use number 1. It's wrong to use number 1. If you use computer to name it, computer I think always includes 1. So in this case I may give you 0 points, and then it's either because it's wrong you use number 1 or computer, either way. But in quite a few instances, computer naming can help, can guide you towards correct answer, but the answer itself is either wrong or not acceptable. And in that case, if you go with the computer, that's a 0. And typically for naming, when I assign points, it's either 0 or full points, because name is either correct or not. Here are some more examples. So methyl cyclohexane, you see we don't use number 1. But if it's open chain compound, you have to use number to indicate where is methyl group, like 3-methylhexane and 2-methylhexane, 2 different compounds. On the other hand, there is only one methyl cyclohexane, that's why we don't need number 1. Typically, when there is only one compound of a kind, we don't need number 1. For example, for alcohol, we'll cover alcohols in a minute, but there is only ethanol and only methanol, because there are, even though we could use number 1, call it 1 methanol and 1 ethanol, but that would be wrong, because there is only one of each. On the other hand, propanol, we have to state whether it's 1 propanol or 2 propanol, because they are different. Now, when we have 2 substituents on cycloalkane, not only that you have to name them correctly, but you have to use number 1. Because if there are 2 substituents, then you have to use 2 numbers. And so, in a ring, first listed substituent is always substituent 1. And note when we use a letter to indicate substituent separate from the name, so 1-T-butyl, 1-T-butyl, and then 3-isobutyl. And so T is not alphabetized, so butyl comes before isobutyl. And here we have 1 isopentyl, 4 pentyl. So iso, this also indicates what is, these 2 examples indicate what is alphabetized, what isn't. So T, which is separate from the rest of the name, is not alphabetized. So it's B versus I when you look at alphabetic order. But iso is part of the name, isopentyl. So it's I versus P. So I comes first. Isopentyl versus pentyl. And now you can see 1,3-dimethyl. We have to list both numbers, same as in case of 2,3-dimethyl open chain compound. As things get more complex, students get more tempted to use computer to generate names and to provide those names. So 1-ethyl-3-isopropyl cyclohexane, that's exactly what I would expect you how to answer this. 1-ethyl-3, and then in parentheses 1-methyl-ethyl cyclohexane, that's probably cheating. I put here cheating. It doesn't have to be. This could be acceptable answer, but you better be able to explain this nomenclature and be able to apply it if you're using this kind of nomenclature. So as I said, I put here cheating kind of for emphasis. It's correct answer. It may not be cheating. And as I said, I may accept it after talking to you. But if you cannot explain it, then yeah, it's most likely cheating. And then if there are 3 or more substituents, then same rules apply. They're assigned smallest set of numbers and listed alphabetically. Because they are now assigned smallest set of numbers, then substituent 1 may not be the first, since you're listing them alphabetically. So here is one example of very complex compound. I don't think I would give you something like this. In fact, this one actually has substituent on carbon 2. Secondary isopentyl, yeah. That would be too complex for you. I would either give you secondary pentyl or isopentyl, not secondary isopentyl, because that would be too complex for you. So this is an example of something that would be too complex to give you on an exam. This would be too difficult. But I might give you, like, let's say, ethyl group here. Instead of secondary isopentyl, it would be 2-ethyl. So then it would be 2-ethyl, 4-neopentyl, 1 secondary pentyl. This is just an illustration with 3 usual rules apply. But while with 2 substituents on a ring, first listed substituent is always number 1. With more than 2, first listed substituent may not be number 1. And if carbon ring is a substituent, you treat it the same way as any other substituent. So here is cyclopropyl versus propyl. Cyclo is alphabetized, so 1 cyclopropyl, 2 propyl, cyclobutane. So that's cyclic compounds. As you can see, that gets more complex compared to nomenclature of alkanes. Okay, here's your question. Can S-butyl also be ethyl-methyl? S-butyl would be 1-methyl-propyl. And again, I would advise you against that. This question illustrates that. Yeah, it says here now. Illustrates that it's much easier to make a mistake. And besides, as I said, it's not that nomenclature is not used much. Typically, we would just call it S-butyl. In scientific journals, it would be S-butyl usually. The only journal that I know that requires this nomenclature, like methylpropyl, and actually 1-methylpropyl, not methylpropyl, but 1-methylpropyl, because 2-methylpropyl is something different, is Swiss journal Helvetica Chimica Acta. So anybody else would accept simpler nomenclature, and that one is encouraged because it is simpler and easier to use. Some people like to use this other nomenclature or other forms. Again, I would discourage that, particularly since most of you won't be chemists anyway. You just, it's important that you learn this material and maybe useful later in whatever you do. But nomenclature is just for you to understand the rest of the course. So I don't see why would you go to that effort of learning some obscure aspects of nomenclature. that effort is much better put in other parts of the course. Haloalkanes. So they contain halogen, fluorine, chlorine, bromine, or iodine. I don't have any iodine here. And here are some examples of line formulas of alkyl halides. By the way, these last two are identical. And I put them here on purpose because sometimes students don't realize that both of these represent tertiary butyl chloride, T-butyl chloride. One here, third from the left, is that often when we draw these formulas by hand, we'll often do it, and I remember when I started teaching, the students get confused by it. The reason why we like to draw this formula is that it's fast. You just draw quickly cross and Cl, and that's it, as opposed to drawing 4 bonds. Not much saving of the time, but when you're doing it all the time, that's how we often do it. And you need to be familiar with this representation, because that's frequently representation, particularly when we do it by hand. When we use computer programs, then this is often the formula. But anyway, two are identical, and you need to know it. Prefixes for halogen substituents are fluoro, chloro, bromo, iod. So you treat them as any other substituent. Now, let's say this name is wrong. Let me see what is wrong. Oh, okay. Yeah, you see, this is one where it's really easy to make a mistake, because if you are given this formula, this would be a really tricky question. There are 5 carbons in the longest chain, and if you look, there are no other chains with more than 5 carbons. So you may be tempted to name it like this: 2-bromo, 3-isopropyl. But actually, there is another 5-carbon chain that has 3 substituents, and you can see that's easier to name. It's easier to name it as ethyl and methyl than isopropyl. Simpler substituents. So always watch for that. If there are 2 chains with same number of carbon atoms, watch for case where you may have different number of substituents. And then if iodine is in place of bromine, then halogen is listed second, because alphabetically ethyl comes before iodine. So halogen is treated just like another substituent. You simply number it and list it in alphabetical order. Okay, in the line formulas of alkyl halides, what is the difference between the 2 Cl formulas listed? There is no difference. So I think what student is referring to are these 2 formulas in this line. This formula third from the left and fourth from the left. There is no difference. They are identical. And you need to know that they represent the same compound. This one, third one from the left, is one that we would often draw when we want to draw something quickly by hand. One on the right, far right, is one that you would usually use to represent this compound, particularly when using computer programs, because it takes the same amount of time to draw both formulas using a computer program. So there is no advantage in doing one over the other. And one on the right, even though it's a Lewis structure and does not represent three-dimensional arrangement of atoms in space, it's actually closer to three-dimensional representation of atoms in space. Because if you, let's say, represent this bond as wedge and this one as dash, you have right away 3D representation. And that's exactly what is problem here. You can represent this as wedge and dash, but it's kind of unnatural. It kind of, if you're a chemist, you right away would know it doesn't really look right. So we would prefer this formula, and usually this is the formula you will get, but sometimes we use this formula. In fact, I used this formula earlier for T-butyl. Let's see, yeah, right here. See, you have it right here. And I may have used it somewhere else, yeah, right here. So it's not wrong to use it, but we often represented differently. So it's like one. It's not wrong to use this formula, but usually not like this. Okay. And there are no other questions. Okay, so let's move on to ethers, I think. Yeah. So nomenclature of ethers, we prefer trivial nomenclature. And trivial nomenclature means that you are naming compounds descriptively. You describe them. So descriptively means what is one substituent, what is the other. You name each substituent. So ethyl, isopropyl, and then ether. That's descriptive. Basically, describe the ether. It's ethyl isopropyl. You list substituents in alphabetic order, and you leave spaces in between. And these ethers are very good on the test to check whether you know substituents, because this is really all about substituents, because last name is ether. It's always ether. So it's just, do you know what are the two substituents? And it's very clear what are substituents because they are attached to oxygen. In other cases, in the previous examples, it may be a little bit more difficult to identify that, a little bit more confusing. Here, it's absolutely clear. You can see 1, 2, 3, 4, straight chain of 4 carbons attached to oxygen. That's butyl. And this you should recognize as tertiary butyl. So butyl, T-butyl ether. Butyl, tertiary butyl ether. When you have it like this, butyl, butyl, you have to put something first because alphabetically they both come together. So then we put butyl, T-butyl. I would have accepted both, T-butyl, butyl. And then neopentyl is one on the left. This is T-butyl and so on. Cyclobutyl, hexyl. So when it comes to ethers, typically what we are looking for is, can you name substituents? And you have to keep spacing because you have to know in trivial nomenclature when there is spacing, when there isn't. In the previous cases, there wasn't spacing in UPAC nomenclature. I didn't cover in exercises trivial nomenclature of alkyl halides, but in those there is spacing. Simply, it's just very easy. I didn't want to waste any time on that. I want to put more time into things that are really important, that's where you would benefit from additional explanation. If something is really easy, trivial material, I'm actually not doing any more exercises on it. There may be videos, there may be exercises in a textbook, but I'm not doing any more exercises on it. So if you are struggling with really simple stuff, if this is really way over your head, then you should be concerned because this is actually easy part of the course. It requires a lot of work. It's all new to you. So it takes a lot of effort, a lot of time to master it, but it's actually easy. Basically, if you put time into it, you should be able to figure it out. But that's not always the case with some material that comes later. But we'll deal with that later. So my point is, if you are already overwhelmed, you already don't get it, that's a concern. We have tutoring, so make sure that you take advantage of tutoring. You can always ask me for help, emails and office hours. But at the end, if you are just not getting it, you may want to drop the course and take this course later when you are better prepared, when you are ready, because sometimes you are just not ready for this course. Okay, so let's move on. Nomenclature of alcohols. So in cyclic alcohols, that's very important. Carbon attached to hydroxyl group is carbon 1. And we never list that one, even if there is more than one substituent. And that's another thing, you see, so cyclohexanol, that's easy. But here, this is cyclopentanol. So this is carbon 1. And then carbon 2 must be ethyl and 3 chloro. So it's 3 chloro, 2 methyl cyclopentanol. That's correct name. Computer would generate 3 chloro, 2 methyl, 1 cyclopentanol. And so that's not correct. And I will give you no points simply because there is 1 here. This is difficult to prove if student provides this, that this is computer generated. Student could have simply made a mistake, but either way, no points if you insert number 1, because that's wrong. As I said already several times, compound is named either correctly or not. And 1, it's not correct, so no points. And then Here is typical computer name. When I ask students to name this, you should name it as, this is 1, 2, 3, 3-methyl cyclohexanol, and that's name, 3-methyl cyclohexanol, it's right there. Computer will typically name this as 3-methyl cyclohexane 1-ol. European nomenclature splits the suffix and inserts 1 just before the suffix. So that's to me a clear indication that computer was used. Now, a lot of students are proficient in that and know not to split the suffix, so they move number before the name. So 3-methyl 1-cyclohexanol, but that's still wrong, because that one that computer inserted is still there. So actually, there should be 3-methyl cyclohexanol. Now, parent chain is the longest chain that contains hydroxyl group. So in this compound, you could actually find longer chain, but it doesn't have OH group. Or chain like this, because that and up. But it doesn't have OH group, not the parent chain. So parent chain must contain OH group. So you look at the carbon that has OH group, you start at that carbon, and then you go around looking which chain is the longest chain. It's 6 carbons. And then you name and number it. And that carbon that contains OH has always the smallest number. In this case, of course, 1. In this case, it will be number 3. So it's smallest number given to OH, not smallest set of numbers. Smallest number given to OH because we are naming it as alcohol. And that tells you for this next compound, correct name is 5,5-dimethyl-3-hexanol. Smallest set of numbers would be actually 2,2-dimethyl-4-hexanol. But it has to be 3-hexanol because it's alcohol. So when you're naming alcohols, because it's an alcohol, then OH must be part of the parent chain and must get smallest number. You are no longer looking for a smallest set of numbers. You are looking for a smallest number to assign to OH. That's different from previous nomenclature that we have covered before, where you were always looking for the smallest set of numbers. Nomenclatures of alkanes, cycloalkanes, alkyl halides. And here is just another example. Computer-generated name is 7-methyl octane 3-ol. Now, computer was pretty good here because it generated correct European name. Again, as I said, some students are proficient enough, they know to move these 3 before octane, and then that's correct name, 7-methyl-3-octanol. That's correct name. That's how you should name it. This is wrong, 2-methyl-6-octanol. Even though it's a smaller set of numbers, it gives 6 to octanol. So 6 to alcohol. It has to be 3, smaller number to alcohol. Okay, so that's alcohols, and I can see questions were popping up. When you're asking questions, I can see frequently that question pops up, but it pops up only for a brief period of time. So all I know is that there are questions, but I can't really read them and answer them at that time. So let's go back and see. Okay. When you have ethers, do you use any numbers? In general, no. You use them in UPAC nomenclature of ethers, but that nomenclature is very seldom used. In UPAC nomenclature of ethers, you use numbers because then you name alkoxy group as substituent and you name it as alkane. And so use numbers the same way as you would do it in alkanes. That's why I didn't cover it, because UPAC nomenclature of ethers, because all it does is it names oxygen substituent as alkyl oxy or alkoxy, like methoxy, ethoxy, isopropoxy, and so on. But otherwise, when you're using descriptive nomenclature, then no numbers. Do you want us to know common naming and not systematic? No, I want you to know both. And on the test, question will be specific. What is the common or trivial name, or what is systematic or UPAC name? So you'll be asked to provide one or the other. And so read question carefully and provide name that you're asked to provide. If I don't ask, then you can provide either one. If I just say name the following compound, then you can provide either systematic or trivial. But that's very rare. Usually I ask specifically for one or the other. Next question. Just to clarify, for monosubstituted compounds and alcohols, we should not include number 1 in the name. That's for cyclic compounds. So whoever asked this, yeah. For monosubstitute cyclic compounds, you should not include number 1. Yeah. I don't know any other cases. That's pretty broad. There may be, but I don't know. Okay, why is 4-bromo 3-ethyl 2-propyl 1-hexanol correct? Okay, I have to look at that compound. When do you have spaces and when do you have dashes? Dashes are used to separate numbers from rest of the name. And the spaces are basically part of trivial nomenclature when trivial nomenclature says so, it's convention. So you use spaces in trivial nomenclature of ethers, of alkyl halides, and of alcohols. You don't use spaces in trivial nomenclature of amines. Okay, let me see, hope I don't remember this. 4-bromo 3-ethyl 2-propyl 1-hexanol. So let me see what is that about. No, here it is. 4-bromo 3-ethyl 2-propyl 1-hexanol. So why is that correct? The longest chain has 6 carbons, because if you look at OH, it starts with this carbon. So you start at this carbon and you look for the longest chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 6 carbons is the longest chain. OH is attached to carbon 1, and then you number starting at 1, number the rest. 2, 3, 4, 5, 6. So 2 is propyl, 3 is ethyl, and 4 is bromo. Now you list them alphabetically. That means bromo, ethyl, propyl. So 4-bromo, 3-ethyl, 2-propyl, 1-hexanol. Okay, should the planet chain include the alkoxy group? Alkoxy group in epoch naming of ethers. In epoch naming of ethers, parent chain is the longest chain. So no, just the longest chain. Should the naming be 2-propyl hexanol? I presume it's the previous question, the one, okay, let me see. I don't know what it means, 2-propyl hexanol. It's 2-propyl. It is 2-propyl, so 4-bromo 3-ethyl 2-propyl 1-hexanol. Yep.
They excluded the number 1 in their answer because they're confused between whether 1 is included
in this case, you have to include number 1. Yeah, okay, that's it. Yeah, you have to include number 1. Okay, yeah, because it's open chain compound. If it's only in cyclic compounds, you don't include number 1. Yeah. So yeah, you have to include number 1. In open chain compounds, you have to include number 1. Okay.
You have another question.
Oh, there is, okay. Why doesn't hexanol come before propyl? Hexanol is the parent chain. So hexanol comes last, it's the parent chain. Okay, finally, nomenclature of amines. Trivial nomenclature is descriptive, which means we name substituents and then we use amine as suffix, so no spacing, so remember that. And we don't indicate primary, secondary, tertiary in any way other than by number of substituents that we list. So cyclopentyl, if we list only one substituent, cyclopentyl amine, that means there is one bond to cyclopentyl, rest are bonds to hydrogens. And so if you're drawing a formula from it, it's going to be NH2. In this case, this would be a little bit more 2-ethyl cyclopentyl amine, a little bit more advanced, and I wouldn't ask you. This is just to indicate what happens if there are substituents on a ring, because In the past, in the class, students would ask me questions like this. And so rather than having to somehow draw this and so on, it's already there. But this would be a little bit more advanced, a little bit more complex. And there is not much to be gained by testing on something like this. Nothing special for me to test, so this wouldn't be on the test. Left formula is fair game on the test, put me on the test. Right one, just to show you how you would name this, but it would not be on the test. Secondary amine, example of a secondary amine. You simply name two substituents and call it amine. N-ethyl cyclohexane amine. This one is UPAC name. So N-ethyl, so smaller substituent is named as substituent, N-ethyl. And then larger chain, cyclohexane amine. So larger chain is considered to be parent chain, cyclohexane. That's also a little bit more complex. Typically for something like this, I would ask you trivial name. And trivial name would be cyclohexyl ethylamine. Again, another example of a UPAC name, N-cyclopropyl 1-butane amine. We have to use number 1 here because nitrogen is attached to carbon 1 of butane. That's UPAC name. This is computer generated N-butyl cyclopropyl. Lots of computer programs have a tendency to assume that the ring is the longest chain. And so that's one of the ways for me to test if student is using a computer to generate names. Typically, when I'm looking for it, whether students on a test is using computer, when there is one instance, so let's say student writes 1-cyclopentanol. That's what computer would put it. It should be cyclopentanol. Computer would write it 1-cyclopentanol. That's not indication for me the student is using a computer, because student may have made a mistake. But when there are 4 questions, and all 4 follow the pattern, where there are all the names, name after name, exactly the way computer would generate it, and all of them are wrong, then I'm pretty confident this student is using computer. So typically, if I'm asking you to explain yourself, if it's only one question, I may just ask you, I want to know, yes, I may want to know whether you have been using a computer, but really I also may want to know why are you making this mistake, because I can then explain you why you made a mistake and simply won't make that mistake again. So typically what I'm looking for is pattern. So typically just one won't be sufficient evidence, but often I see in students, if there are, let's say, 5 or 6 questions on a test that are nomenclature questions, and every single one is kind of question the computer will provide, then that's indication to me this student is not studying, this student is just typing it up and typing it up into a computer program and cutting and pasting it. So in red is shown that you see computer assumed that cyclopropyl is parent chain, but actually it's butyl. And again, I would prefer on a test to, I gave you this here because I want to show how computer does it. But on the test, I may prefer to ask something like this, again, as trivial name. And so this would be butyl cyclopropyl amine. And this would be secondary butyl cyclopropyl amine. And again, trivial name. Trivial, this is systematic. You see difference between 1-butane amine and 2-butane amine. Nitrogen attached to carbon 1 of butane to carbon 2 of butane. That's systematic nomenclature. This may be my phone. Sorry about that. This is computer. That's why I want to have it here. So this is computer generated name. So again, it is correct. Oh no, it's not correct. You see, yeah, this would be a typical indication for me that student is using computer because substituent has been named according to very strict UPAC rules, and it's very easy to program to give a computer program to code it to use these rules. It's much more difficult for human to come up with this name, and also so that's one indication. And second, assumption that a ring is the parent chain. So this would be kind of, to me, I would be confident that somebody, whoever wrote this, used the computer. What was your question?
Oh, I just read it, so I think I answered it myself. But just to verify, in that one, we could say to butane. I can't pronounce it.
No, no. You either say 2-butane-amine or S-butyl.
Okay.
You can't say 2 and S because 2, this is carbon 2. So if you're using UPAC nomenclature, it's going to be 2-butane-amine. So cyclopropyl 2-butane-amine. If you're using trivial nomenclature, then it's going to be S-butyl cyclopropyl amine. Yeah.
So you put cyclopropyl before butyl, it's a shorter chain.
No, butyl before cyclopropyl. Sorry, in trivial nomenclature, list them alphabetically. Butyl before cyclopropyl. Now, in systematic nomenclature, you put cyclopropyl before butane because it's substituent, it's shorter chain. Yeah, and cyclopropyl. Yeah. Okay, we are at the end. So let's see what are the questions because I noticed some questions popped up. What was trivial name for the first one again? I don't know what is the first one, so somebody, whoever typed this up, needs to clarify this. Will the nomenclature questions be multiple choice or written response? Both. So as we get closer to the exam, I will explain to you, but about a quarter of the questions are written response, very short written response, and 3/4 are multiple choice. And so some of these will be written responses and multiple choice. Can you explain again how you get the answer for N-cyclopropyl 2-butane-amine? So you have nitrogen, and longest chain has 4 carbons. This ring has 3 carbons. So 4 carbons, that's butane. Nitrogen is attached to carbon 2. So it's 2-butane, and because it's amine, suffix amine, 2-butane-amine. Substituent to nitrogen, only 1, that's N-something, N-cyclopropyl. So that's systematic nomenclature. So systematic nomenclature, you look for the longest chain attached to nitrogen. 6 carbons, cyclohexane. So it's cyclohexane amine. And then whatever is on the nitrogen is N-something, N-ethyl. Because this is ring, we don't use number 1. When it's open chain, 4 carbons, longest chain, nitrogen attached to carbon 1, 1 butane. So 1 butane-amine. Substituent and cyclopropyl. Okay, let me see for the first, whoever asked for the first one, if that person clarified what was the first one. Okay, whoever asked this, what was the trivial name for the first one again? I don't know what is the first one, so you need to clarify that, and that's it, then I can let you go. And ethyl cyclohexane. Okay, this one. Oh, trivial. So trivial name for this would be cyclohexyl ethyl amine.
Please explain the difference between
Trivial is descriptive. So you name each of the substituents, 1, 2, or 3, whatever how many substituents you have. You list them alphabetically, and then amine. So substituent, 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 amine. If there are three, that will be tertiary. If there are two, then you list two substituents. If it's one, just one. And you list them as substituent: methyl, ethyl, propyl, isobutyl, tertiary butyl, neopentyl, cyclohexyl, whatever substituent is, you list those substituents, and then word amine. That's descriptive. Systematic nomenclature, longest chain that contains nitrogen. And then, if necessary, use numbers. Numbers are necessary always, unless you have a ring. So to which carbon nitrogen is attached. So it's that alkane, you name it as alkane, let's say 2-butane, you drop the final E of butane and replace it with suffix amine, so 2-butane amine. And then any substituents of nitrogen, you list as N something, N substituent. Yep.
So the end in front of like the ethyl and cyclopropyl, is that to denote that it's attached to the amine?
N means attached to nitrogen.
If so, is that also included with the trivial thing?
No, no, N is only systematic nomenclature. Does alphabetization? Yeah, it does matter. Yeah, trivial nomenclature, you also list substituents in alphabetic order. Okay. Any other questions? Okay, any questions about anything we covered today? Okay, then that's it for today. Next day, Monday, we will start chapter 3. So watch all the videos and read all the material about it.